Thanks again to everyone for joining us today. I want to start by acknowledging the recent acts of racism, violence, and injustice that I know are still very present in all of our minds. The Nature Conservancy, we work really hard to help create a world where people and nature thrive. Racism threatens this goal, it hurts our communities, and it puts vulnerable lives at risk. A few weeks ago, our new CEO, Jennifer Morris, put out a statement titled, "Environmentalists Cannot Remain Silent on Racism." In it, she committed that TNC would keep equity, diversity, and inclusion top of mind in both our workplace culture and our conservation outcomes. And she also committed that we would help to lift up the voices of communities who are vulnerable, marginalized, and historically underserved by systems in our society. In Maine, we are making this work a high priority, and we're committed to examining our own privilege and our responsibility to create positive change. We know that conservation and the conservation movement has contributed to divisions in society, and we also know that there are important ways that conservationists and environmentalists can help to address social equity. And tackling climate change is a great example of that. Communities of color and other socially vulnerable communities are disproportionately at risk from the effects of climate change, including sea level rise. So understanding those risks better and taking steps to reduce them has the potential to help all people and nature thrive. And that brings us to our topic for today and our discussion about climate change impacts like sea level rise and flooding, and what TNC in Maine is doing to help communities to prepare. Before we start though, I want to make sure that you all know that this is happening because of you. Your support for TNC and your commitment to our mission are essential to making it possible for Jeremy and the rest of our team to do the work we do every day. So truly, on behalf of all of us, I thank you. Now I'm going to give just a little background on the Nature Conservancy. As you all probably know, our mission is to conserve the lands and waters on which all life depends. Our projects are always local, but we operate at a global scale. We are active in more than 70 countries and in all 50 of the United States. Our approach is collaborative and science-based and guided by our global shared conservation agenda that helps us tackle some of the biggest challenges facing nature and people today, in particular, ensuring healthy oceans, fresh water, and lands, and tackling climate change. In Maine, we draw a lot of strength and pride from our history, and from people like Rachel Carson, who is one of the co-founders of the Maine chapter. She said, "The Nature Conservancy is the only group I know which is doing something practical about actually preserving areas." I'm going to give a high-level overview of the work we're doing now in Maine, and I'm going to start with the work that has the deepest roots for us, conserving the future of forests. Maine's forests are part of one of the largest intact blocks of this forest type left anywhere in the world. And our science has shown that this region is also one of the areas likely to be the most resilient to the effects of climate change along the East Coast. We have a goal of maintaining a connected network of more than 10 million acres of forest across Maine, and strategies to help us get there. And the story is similar for the rivers of Maine. Our state is home to some of the least disturbed watersheds in the eastern US, and we believe some of the most resilient. We still have the challenge of many dams and old road stream crossings like this one that block the annual migration of fish. But we have a plan to reconnect more than 1,500 miles of river habitat and hope to soon have more than 20 million fish returning to our rivers each year. This work benefits communities around the state, keeping roads safer from floods, and it also has big benefits for the health of the Gulf of Maine, where we are working on a set of strategies to transform the systems of ocean management. The Gulf of Maine is one of the most productive marine systems on Earth. It's also under a lot of stress, with many important fish populations depleted and water temperatures warming at a rate faster than 99% of the world's oceans. We've been working for more than 10 years to restore the health of the Gulf of Maine, partnering with the fishing communities that depend on it for their livelihoods in ports from Maine to Rhode Island. We are also deeply committed to inspiring climate action, and this includes helping to reduce emissions with state and regional policies, piloting demonstration projects, and working to change the way people talk about climate change. We were incredibly proud to help Governor Janet Mills and many partners to pass groundbreaking legislation last year that sets Maine on a path to being carbon neutral by 2045. We're also hard at work helping people and natural communities adapt to the climate changes we already see. And that brings us back to our topic for today, climate change in your neighborhood, sea level rise, and flooding. Our guide today will be Jeremy Bell, Maine's Climate Adaptation Program Director. And Jeremy's worked for TNC in Maine for more than 6 years, overseeing our coastal and river restoration programs. This has included strategic work to help increase conservation funding and capacity around the state, as well as identifying the best opportunities for on-the-ground restoration projects. And just this spring, Jeremy's role evolved to focus entirely on our climate adaptation work in Maine, which, as you'll soon hear, is critically important. So we're very excited about that. Before coming to TNC, Jeremy was the Wetlands Program Manager for the Massachusetts Division of Ecological Restoration and a project manager there for nearly 10 years. So you are in great hands, and we have an exciting conversation ahead. So thank you again, everyone, for joining us. And now I will turn it over to Jeremy.
Thanks, Alex, and hello, everybody. It's great to be with you today, and thanks so much for joining us for this presentation about sea level rise. Just give me one moment here to share my screen. Okay, does everybody see the presentation? Is it up well? Okay, great, thanks. Okay. So, sea level rise is a significant issue along our coastline, and a vast majority of our population lives along the coast, as you can see in this slide. In addition, some of our most important economic elements of our economy come from the coast. And last but not least, our coast is home to immense natural beauty with opportunities to enjoy nature. Sea level rise threatens our way of life along the coast. And here we have a graph of sea level rise at the Portland gauge. And Portland has experienced nearly 8 inches of sea level rise in the last 100 years. And we are set to see an additional 1 to 4 feet of sea level rise in the next 100 years. Now, I added this article from the Bangor Daily News to help illustrate that sea level rise is not a distant issue. This is very much an issue that is affecting our communities right now. The value that you see here, the $70 million of loss, is from a study by an organization called First Street Foundation. And this shows the home value loss in a 12-year period ending in 2015 for Maine's coast. And we can expect to see further losses into the future. Okay, and here's the question of the day. Over the last several years, we've developed several web-based decision support tools that help us address climate adaptation and plan for a changing future. Now, the first tool we developed is on the left. This is our marsh migration tool. You'll see it when we do the demo of the Coastal Risk Explorer. We developed this tool in conjunction with the Maine Natural Areas Program. And the next tool that we'll be discussing today is the Coastal Risk Explorer in the center. And then on the right, you see the Inland Flood Risk Explorer. And this is a tool that we've been working on to work with inland communities on road stream crossings to predict flood events from extreme rain brought on by climate change. So as I said, today we'll be discussing the Coastal Risk Explorer. And this tool is very much based on the best available science incorporating information specific to Maine, and we're really proud of this. And so what we did was we started with high resolution LiDAR data of Maine's coastline. And then what we did was we added in, if you notice at the top of the, just above the map, there's a sea level rise predictor. So I'm adding sea level rise now to the topographic map, as you can see. And so we went from 1 to 3.3, which is a meter and 6 feet of sea level rise. And that's work done from the National Climate Assessment, I should mention, and the Maine Geological Survey. The next thing we did was we added in comprehensive road data. This is called the E911 roads data, which is the data emergency responders use to get to your address in an emergency. We also added in the E911 address points, which are the black squares on the map. We added the hospitals, which is the plus in the upper left-hand corner. And then what you can see here is we ran an analysis that shows the red lines. These are roads at that 6 foot of sea level rise inundation at high tide. Those red roads are underwater in that scenario. Now, the next thing we did was we did an analysis of roads and address points that are inaccessible to emergency services because those red roads are inundated with water. And so you can see here on the map, there are some yellow sections of road. Those aren't necessarily underwater, but the emergency services vehicles cannot access those address points because there are flooded roads in the way. Sorry, I lost my cursor here, just one moment. Okay, so we also added in, and I'll talk about this further, approximate cost to upgrade those inundated roads. And then we added something that I'm very proud of, which is we developed with Bowdoin College and Blue Sky Planning Solutions, our partners in developing this tool, a social vulnerability index for using census block data information from the US Census to show which communities are more vulnerable than others from the effects of sea level rise and other events. We'll be looking at that further as well. And here are the measures you can see in the orange box. Okay, so now we're not going to show a live demo from the web tool. These are still shots that I can walk you through to show you what the tool does and how it functions. However, a live demo with pulling data off the web and serving it out to all of you wouldn't work very well. So we did stuck to still shots of this. So here's what we call the landing page. If you go to the web address here where it says maps.coastalresilience.org/Maine, you'll come up to our landing page here. And Elsa or somebody else, if you could put that in the chat, I would appreciate that web address to get to that point. And so we have 3 tools on here. We have the Future Habitat Explorer. That's the marsh migration web tool that I discussed with you earlier. We have the Aquatic Barrier Prioritization, which is about sea-run fish in the Penobscot. That's a tool I haven't told you about yet. And then lastly is the Coastal Risk Explorer. And so what I did here was I highlighted the 2 ways that you can enter the tool. On the upper left in the black sidebar, there's an icon. If you click on that icon, you can get into the tool. And also at the bottom, the Coastal Risk Explorer button with the lettering, you can also click on that. Just make sure you choose one of those two options. That starts the tool for you. Okay, so once you choose one of those buttons, you can see again Maine's coast outlined in the dark gray, and then also that sort of gray-green color is the current sea level in present day. So now to get down to the finer scale, what you need to do is choose a town, and I chose Old Orchard Beach as a model town for this demonstration. And so you click on the drop down, scroll to Old Orchard Beach, click on Old Orchard Beach, and then it brings you in to the town level. So once again, we see the sea level rise predictor at the top, and you can use your cursor, your mouse cursor, to slide up and down to choose the sea level rise scenario. And so we'll just walk through those right now. So note on the map on the right-hand side of your screen, you can see where the current sea level rise is. As I said before, we just add in 1 foot of sea level rise here. And now what we're seeing again, the red line showing roads that are inundated at high tides. And then you can see a few address points, those yellow points next to the red road lines that are homes that are inaccessible to emergency services. Also, in the window on the left, I don't know if you can see my cursor, but what the tool does is it predicts the number of address points in Old Orchard Beach. This is an important part, 344 addresses that are inaccessible town-wide. Well, I'm just showing you a small portion of the town, but town-wide, just know that at that 1 foot of sea level rise, there are 344 homes that we are predicting will be inaccessible. And also, to the right of that number is an estimate to upgrade the roads so that they wouldn't be flooded. Okay, next, we move up to the 2 foot sea level rise scenario. Note, you can see much more inundated road and also an increasing number of homes inaccessible to emergency services. And then lastly, the 3.3 foot scenario, an increasing number of roads underwater, over 600 homes, and over $14 million of cost town-wide. And now, due to time, because I'd like to be able to interact with you in the Q&A, I'm not going to show the 6 foot scenario, but one interesting anecdote about this is that when we were developing this tool 3 years ago, the 6 foot scenario was considered the extreme high scenario for sea level rise. We debated whether or not we should even put that on the tool because we did not want to be seen as alarmist. Finally, we obviously made the decision to put it on there and have the information out to the public. And now there's a new national climate assessment analysis. The new extreme high scenario is 10.8 feet. And so you can see the science is changing rapidly. And I think it also justifies this decision to add this 6 foot scenario, which is now considered a moderate high scenario. And to me, this just adds a sense of urgency to our work to try to adapt to a changing climate. Okay, now addressing again the social vulnerability analysis, what I did was at the bottom of the screen, you can click on the social vulnerability index. And so now what you're seeing is from dark to light, most vulnerable to least vulnerable census block groups in the town of Old Orchard Beach. And additionally, I clicked on the center of town here. And so that's outlined in green. And once you click on a census block group, the metrics, number of inaccessible homes, and the cost to upgrade those homes also appear below the townwide numbers. So you have the townwide numbers at the top, and then you have the census block group numbers at the bottom. And so once again, back to vulnerable communities and equity in climate change adaptation. The concept behind doing this social vulnerability index is to give an opportunity for planners and decision makers to try to work with our most sensitive populations to equitably distribute resources for climate adaptation, and give focus to community efforts for adaptation as well. Okay, and then the last thing, sort of in the bell and whistle department, but I think it adds value to the tool, is here in the lower corner of this information window, you see this half moon icon. What I did was to make these backgrounds transparent. If you click on that half moon icon while you're in the tool, you can change the transparency as much as you'd like, so you can see the context of where the sea level is in the community and which homes are being inundated and how that fits into the bigger picture of the topo map that's behind it. So I had the transparency set at about 50% here. And so in closing, I just would like to say that the reason why we created this tool at the Nature Conservancy initially was to make a tool to talk to folks who aren't necessarily conservationists, but also over time it's become clear that protecting people from the effects of climate change can have really negative effects on the environment. And so one of our goals with our work on adaptation and resilience is to help people plan for the future, not only for their own safety, but also to protect and conserve nature while we do that. And this is a really important goal of our work. And we're trying to use tools like this to protect people and nature at the same time. So thanks very much for listening.
Excellent. Thank you, Jeremy, so much. So we will stop sharing the presentation here so you can see some faces a little bit larger. And what we're going to do now, as Elsa described, is we're going to open it up to questions from all of you. So if you look at the very bottom of your screen or the bottom of your Zoom window, you should see a button that says Q&A. And if you click on that, you can type questions directly in there, and we will be working our way through them. And I'll be posing questions to Jeremy on your behalf. And any questions that I can help to answer, I will. So hop on in there and start typing. Looks like we already have a couple in here, so I will, Jeremy, I will just guide us through. So let's start off with this one. So who are you seeing that's using these tools now, and do you have any data on the actual usage, or how many and to what extent?
Yeah, I mean, I think in the bigger picture, well, first of all, let me just say the response to the tool has been much more than I expected. And that's been really gratifying. I think we expected it to make an impact, but it's been, honestly, at first it was overwhelming. I didn't expect it to be so well accepted, but like I said, it's been very gratifying. And so I think probably the #1 user has been town planners, town managers, and consultants working for towns to do sea level rise planning. For example, just a couple of examples, the Portland and South Portland recently did a unified planning effort, and they asked us for the back-end data so that they can incorporate that into their adaptation planning. I was very proud of that. We've also seen the town of Vinyl Haven, which is one of the leaders in sea level rise and adaptation planning in the state, use the tool as well. The town of Machias has used it as well in their sea level rise planning, incorporated into their thinking. And so it's catching on in communities. Those are just a couple of the towns that have been using the information.
Excellent, thanks. So another question, are you seeing or you anticipating municipalities adapting existing neighborhoods and infrastructure based on this results, or actually looking to migrate communities using open space that exists elsewhere to move inland?
Yeah, that's one of the universal questions of adaptation planning, I think, is do you protect what you have? Do you move inland? And I think it's going to be very much from what we've seen in other places, such as Florida, which has a lot of low-lying land, is that it's going to be a combination of strategies. And it may be early on that folks protect roads and that those costs are acceptable. But at some point, there may be places that the costs outweigh the benefits in the eyes of the decision makers, or in the eyes of an individual homeowner, even to make that decision to move out and go elsewhere, go upland, for example. And so I definitely think that there's a place for all of those strategies, and it's just going to be up to individual states, individual communities, individual homeowners to decide when that tipping point is of when it no longer makes sense to stay in a given location. So hopefully that answers the question.
Great, yeah, thank you, Jeremy. A couple of questions related to sort of rollout and how you're sharing information. So, what are your plans for getting the word out, and anything in particular that you're doing to help inform planners about how they can use this tool?
Sure, we've done multiple presentations to different communities. Some we've reached out to directly to do presentations. We've also been invited to give presentations for specific towns. And one that comes to mind is the town of St. George had a sea level rise planning meeting this past winter, which feels like eons ago now, it has to be said. They invited me to a panel presentation on sea level rise. And usually when you go, it was January, it was a dark night. Maybe you would expect 20 people would be a good turnout. There were over 100 people there of all ages, literally from 10 to their 80s. And so it was a really, there was energy there about protecting their community and gaining information to help them plan for the future. And that was one of the most inspiring meetings that I've been to, where I've been able to talk about this work, because the passion to protect their community and their way of life at the same time was that was just it was a special moment for me. But to get to future plans, I'm working with a group of partners, including the developers of the tool in Mid-Coast Maine, to start doing some outreach and some more intentional planning sessions to try to bring people together, and mainly in Saginaw County. And so we'll be rolling that out in the next year. And then also, now that I'm in this new role and I have the capacity to do this full time, which I'm excited about, is we can start doing this in other sections of the coastline as well. But also, I think hopefully this work can inform a broader planning effort and a more unified planning effort in the state that gets behind some of the goals of the Maine Climate Council, which I think has been an excellent process. And so I'm hoping that we can sort of start to roll this up to a broader strategy in partnership with the state and our other NGO partners.
Thank you, Jeremy. There are a couple of questions related to both the timing and the source of information for the sea level rise predictions. So, particularly both for that new 10-foot rise, if you could say anything to where that source is coming from and any timing expectations, and then also, just any context for how those predictions are made and how likely it is, because we are seeing data change so quickly. So how is it calculated and how does it change?
Sure. Okay. Yeah, so the information all comes from the National Climate Assessment, which is a project of multiple federal agencies. And so that's the starting point. And so every few years, I forget the exact interval, they redo the science, rerun the models that create those sea level rise predictions. And so then in the state of Maine, the Maine Geological Survey interprets that data and then releases the data set. And that's the data set that we use. So it's National Climate Assessment and Maine Geological Survey data in that instance. And so 3 years ago when we started using the tool and we started developing that data set, we were using the current prediction at that time. And so like I said, in the last year, a new national climate assessment report came out, and with those new sea level rise predictions. And so that's where that 10-foot extreme scenario comes into play versus the 6-foot from previous. And so how the model is created is very complex. I won't pretend to understand it, but essentially it's things like as the ocean warms due to climate change, because the ocean is absorbing a lot of the heat from climate change, the water in the ocean expands, and so that's partially one of the causes of sea level rise is expansion of the ocean as it warms. The others are, we've heard a lot probably on the news about the melting of the polar ice caps and those sorts of things, and it just sort of depends on the rate of change of those really big variables that influence how sea level rises. And like I said, that's a broad brush right there. Beyond that, I'd be treading on thin ice, I guess, to explain it further than that. But that's sort of in a nutshell how it's created.
Excellent. Here's one that relates to the direct habitat implications of sea level rise. Are you seeing coastal marsh migration keeping up with current sea level rise, or how is that playing out along Maine's coast?
Yeah, and I would say Maine is better positioned than other places in the world for marsh migration and current marshes actually keeping pace with sea level rise. So our tides range from a vertical change of about 10 feet in southern Maine to 16 to 18 feet as you get towards down east. And in places where the tide ranges are bigger, which we have bigger tide ranges than, say, for example, Narragansett, Rhode Island, the tides are only a couple of feet in a lot of places, some even less than that. Woods Hole, Mass, for example, 1.5 foot tide range. And so in places where you have very small tides, the marshes are much more a threat than in places where the tides are bigger. And it's essentially, from what I gather, it's because the percent of sea level rise in a really narrow tide range, it's a much bigger percentage of water that the marsh has to deal with, as opposed to our marshes that are used to 10, 15, 20 feet almost of sea level, of tidal exchange. And so Maine's marshes are doing better, but that's not to say that they will be able to keep pace with these future changes in sea level, because as we saw, these numbers are very unpredictable and are probably going to go up very rapidly. And so honestly, we just don't know what the future holds. Right now it's good. And what we want to try to do is hold on to the marsh that we can, protect the areas in the upland where the marshes can migrate, make sure they're not developed, and then that way the marshes hopefully will have somewhere to go in the future.
Great. So there are a couple of questions related to the cost estimates that are in the model. And if you could just sort of restate again what those apply to, whether they apply to the census block groups, and also if there's kind of a range of potential costs for towns that you've seen from the model.
Mm-hmm. Okay. Yeah, it's a great question about the roads data. And so what we did was we took the linear feet of road and we simply multiplied by an road upgrade number that we got from a DOT publication from right before we developed the tool. So that would have been 2017, I guess, at that point. And so that was a simple multiplication. So it's a very basic number, and it's not intended to be it's intended to be a conversational number and not necessarily a planning number, I guess, if I could say it that way. The census block groups, what we did was we broke out the information. So we have I showed the example of Old Orchard Beach, and when you zoom in and you create you add sea level rise onto Old Orchard Beach, you can get that town-wide number of an estimate to fix all the roads in Old Orchard Beach. But if you click on the census block group, then you just get a subset of the roads that are actually inside that census block group.
Great. So a question, you mentioned in one of the overview slides that there's also an inland flooding tool that's under development. Wondering, someone was curious if you could speak a little bit more to that and how this might be applicable for inland communities.
Sure. And we realize everybody doesn't live near the coast, and we want to make sure that we provide adaptation solutions for all Mainers. Like I said, and back to the equity piece, this is a really important aspect of our work, and so that's one reason why we undertook this inland flood risk scenario. And I shout out to my colleague Ben Matthews, who's not on the call today, but he was the mastermind behind the modeling effort that was significant for this tool. We have over 20,000 culverts in a database that were hand measured. And as far as size and type of stream and that sort of thing. And what he did was he developed a model looking at stream flow data to predict when those culverts and the road associated with the culverts would overtop. And that's a really, well, first of all, if the road overtops, then it's a similar tool to what we have here. A similar problem, I should say, is that the road is underwater, and so therefore can't be traveled on. And the other aspect of it is that it's not quite a proxy for it, but when a road overtops because of a flood, there's a high chance of failure, a good potential for failure. And so these are also problem areas for communities as far as losing road infrastructure. And so we're the Nature Conservancy. We've always cared about sea-run fish. Those, you know, my previous job was to upgrade roads for fish, but there are also incredible benefits for flood safety as well. And so because most town budgets are not created based around sea-run fish safety and healthy population numbers, we wanted to take a different look again at this problem for inland communities and create this tool that will basically show communities where are the hot spots of culverts that would be problematic potentially under certain flood scenarios. And they're not even big flood scenarios. These are actually relatively small and increasingly common flood scenarios, like the 25-year storm event, which has about a 4% chance of occurring every year. So every time you roll the dice, you have a 4% chance every year to have that 25-year flood, and that's not a huge flood, and they're getting increasingly common. And so what we wanted to do was provide a planning tool, like I said, for inland communities to be able to proactively look at the safety of their road systems as well.
Great, thank you. So a question on working with partners and GMRI in particular, and the comment was that one of the participants has seen some tools that GMRI has described that seem similar, and it seems like there's a overlap of concern and interest in this area. And so the question was, you know, to what degree has TNC and GMRI been working together on work like this?
Yeah, thanks for that question. And I've given a few presentations with Gail Bonus, who is their sea level rise expert at GMRI. She and I are good colleagues together. And I would say their focus has been more on education and outreach of communities, sort of explaining the science behind sea level rise. And I believe that the sea level rise predictions that they use are sort of national level NOAA data. And so the difference, I would say, is, and we've thought about this too, you know, creating yet another tool. And the difference here is the resolution of what we're providing is really meant to go down to the individual home level and those 911 address points. And so we have really high precision topography of the landscape and these roads and the analysis. It's a statewide analysis, but it's also meant to go down to really fine scale. And so compared that to the NOAA data and the NOAA sea level rise tools, which are fantastic tools, and they're more regional scale tools, planning you know, at multiple state level tools, but they won't get you down to the level of looking at the individual property in Maine, for example. And I believe that that's what the, if I recall, that's what GMRI uses with theirs. But back to the original question, we're great partners with them. We've collaborated quite a bit in the past on this and other things as well.
Great. So I have a pair, so a comment from one participant and then a related question from another. So I'll read the comment first. And this was someone who has had a conversation or heard a presentation on sea level rise from a leading banker. And the banker's quote was, "Long before your ankles get wet, the community will suffer because mortgage loans will dry up and no one will be able to buy or sell houses with financing." And then the paired question is, how is Maine addressing home and property insurance in flood risk areas? And at what point are there policy changes that, that change the incentives for building in those areas?
Okay, and thanks for both of those. And remind me, Alex, if I forget to address one.
Sure.
But the, yeah, and I did see an article in the New York Times recently, and I'm not sure if the, you know, the person who asked the question also read that article, but the title was something like "The 30-Year Mortgage as an Institution is at Risk." Mm-hmm. That's the sort of the paraphrase gist of it. But so yeah, I agree with that premise 100%. That First Street Foundation publication on the $70 million of loss of value of Maine homes, I think that's only going to go up, and I think that there are going to be properties depreciating because of sea level rise and becoming less desirable because of sea level rise. And so then the second part of the question, I forgot. I was concentrating so much on that first.
Yeah, no, it had to do with any sort of policy changes and work that's happening right now in Maine to try to address some of these impacts or to plan ahead.
Thanks. Yeah. Okay. Yeah, I would say a lot has been done in the Maine Climate Council, which has been a fantastic planning process, a whirlwind process, but fantastic. And I'm on the Coastal and Marine Working Group of the Climate Council, but I've also attended meetings of the Community Resilience and Emergency Preparedness Public Health Group. I would say that's probably the biggest place for policy change and suggestions that to sort of improve the regulations and the management along our coastline and other places to encourage, you know, positive development that's out of floodplains, those sorts of things, conserving nature while protecting ourselves from the effects of climate change and those sorts of things. So I think that's probably, I would point to that, but also the Transportation Working Group has this, you know, really robust section on adaptation as well and trying to protect roads. And Maine DOT, I have to give a shout out to Maine DOT for doing some really excellent planning work in this arena, increasingly interesting and I think valuable work for Maine as well. And so I think between those working groups and the suggestions that are in there, I think that's probably our path forward.
Great, Jeremy. And I will, in a minute, in the chat, I'll share a link to that New York Times article about the 30-year mortgage question that Jeremy raised. So a couple of related sort of mirror image questions or comments. So one participant had asked if there have been questions or concerns raised about the model and the data behind it and any attempts to undermine the credibility. And then another participant who says that, you know, they have been a property owner in Maine for 30 years, haven't seen any evidence of sea level rise, and have read data that suggests that there's very little evidence for acceleration of sea level rise since, you know, in the last 100 years. So, you know, kind of a question raising a concern, and then also a broader question about how the data are put together and how you respond to questions about the credibility of the predictions.
Yeah, I mean, well, getting back to the National Climate Assessment data, there's definitely uncertainty in the sea level rise predictions because we don't know what the future brings as far as you know, the warming temperatures. And so I think that that's one of the things that people have latched onto as a reason to poke holes in climate data in general. But just because there's uncertainty doesn't mean that we don't understand that there's change happening and happening rapidly, and will increase in pace over the coming years. And so to the comment about the person who's lived in Maine for 30 years, previously it's only been in the last few years that the sea level rise predictions have, that sea level rise has started to increase in pace so quickly. And so what you would have seen over the last 30 years is a fairly slow, say 3 millimeters a year of sea level rise, which to the eye is not a very noticeable change over time. And so it might not look like it's happening, but it certainly is, and the data shows, for example, that slide that I showed before about the sea level rise. We're just after the inflection point of where the sea level rise predictions are going to go up very rapidly, and you will start to be seeing the changes where you can just go out to the beach and eyeball it immediately. But I would say prior to this, it's not as easy to see. And, maybe part of it is some of a snapshot of, the time we're living in, but there are certainly old cart path roads that were built in the 1800s that were high and dry in the 1800s that are underwater now. So there are places sort of in, Peninsular Georgetown, Bath, Pittsburgh, those sorts of areas where there are certain roads that are under, some roads down east, that those roads very likely in the 1800s were not underwater at high tide, and they are now. And so there are those differences that you might not see, like I said, in the present day, but certainly have happened over time.
Great. And just a note on time, we have a little more than 5 minutes left. So if you have any last questions burning, please put them in the Q&A box now, but we do have a few more up here. So Jeremy, the base data that you described was LIDAR, which is this an acronym that I don't remember exactly, low intensity data radar or something, but there's very high resolution flown data that we're getting available for more and more of the coast. And the question was, is that data changing the way that flood zones are being mapped by the Federal Emergency Management Agency?
That's a good question. First of all, on the acronym, I don't know, you did better than me, but essentially it's, I can't remember the acronym, so I apologize for using it and then not even knowing the words behind it. But essentially it's an airplane that flies and shoots a beam down at the earth and then takes in really high accuracy elevation point off of that beam, thousands and thousands of beams flying over the coast of Maine, for example. And so the second part of the question was, again, I'm sorry.
Oh, the flood zones and whether the better data are changing how flood zones are being mapped.
Yeah, probably slowly. I don't 100% know the answer to the question, but my guess is that that probably the answer is yes. For example, some of the FEMA flood maps are 25 years old now, 30 years old, and that predates LIDAR data. And so I'm guessing that because I do know the way they model the FEMA flood zones is they take specific sections of the coast and they do a flood model on it. And so the better data that you have going in, the better data that you're going to have coming out the other side. And I would assume that they're using the best available data on that topography and all the other, the sea level rise data, storm surge data, and those sorts of things. But definitively, I can't say that for sure.
Okay. A question going back on the cost estimates, and the cost estimates that are currently in the model look at and estimate the impact to upgrade roads that are affected. And the question was, have you given any thought to whether those cost estimates could also include impacts to home and property values?
We definitely talked about that at the beginning, and we decided that First of all, it's very complicated, and so we wanted to get something out quickly that was a simple, you know, I say simple. It was complicated to actually execute this, but a simple problem of a flooded road, and so we decided to go with this as an everyday nuisance problem or potentially emergency services related problem to address that one issue and sort of center the discussion around that. But it's definitely valid to consider these other impacts like the economic impacts. And so that would be a key part of figuring out the economic future of Maine's coastline. And so I think that it may not be in this tool, but that's something that would be critical to do to figure out how we make progress forward as a state, because even a coastal homeowner's property value, that affects not just that property, but it's going to affect all of the citizens, because in totality, it affects the tax base of the state. And so, the same way flooding of a farm in Aroostook County affects us all, so does the sea level rise program sea level rise problem. Sorry, sea level rise problem affect us all the same, and so we definitely need to do those economic analyses. There is some of that starting to be done in the Climate Council, but I think more to come on that as well.
Great, thank you. And I'll just to add to that, one of the things about this that attracted us to develop this tool in this current application is that it is something that can be updated. And so this is version 1.0 of that tool. And I think there have been some great suggestions coming in from towns and emergency management planners. So that's a great suggestion. There's one more question. Someone also kindly shared the definition of LIDAR. It stands for light detection and ranging. So I think maybe I got "and" right. Okay, last question, Jeremy, of the day is, do you have any other presentations coming up? And have you done presentations that include both town planners and conservation committees or land trusts to sort of bring groups together to think about combined responses? And if not, just any upcoming talks that you have just to help get the word out.
Yeah, I don't have any upcoming talks, but we do plan, like I referenced before, the Saginaw County planning exercise, where we're planning on using the Coastal Risk Explorer to do scenario planning with different groups like emergency management, social services agencies like the Red Cross, faith-based groups, and also conservation groups. So we will, as part of that process, be bringing people together, and that's very much been led by our friends at Bowdoin and Blue Sky Planning, who helped us develop this tool, and I'm partnering with them on that project as well. So we do have that planned for the future. And just an observation about, well, when a few years ago when we developed the marsh migration tool, my primary audience for that was land trust communities. They showed the marsh migration viewer, and we had a great talk about marsh migration, but always the conversations, the Q&A part, ended up on the economic impact of sea level rise, and these are from avid conservationists, passionate conservationists, but we always talked about insurance premiums, home value loss, those sorts of things, and so it's very much it's a broad issue that I think we could easily expand that back to the point of the question. We could definitely integrate those audiences more thoroughly, I think, in the future.
Great. Okay, well, thank you, Jeremy, so much for fielding all those questions and sharing all that great content. If you haven't had a chance to click on the link in the chat, or if you have any questions about the content here, you can follow up with us after, and hope you'll explore. And if you have any issues using the tool, please let us know. That's the time that we have for today. So wanted to thank everybody again for joining us, and also for everything that you do in partnership and support for the work of the Nature Conservancy, which really makes a world of difference for us and for the state of Maine and the people of Maine. So thank you all, and we look forward to talking again soon. Take care, everybody.
Thank you. Thank you so much.